please.
Yeah, that's a blush. That's a blush. Okay, awesome. Now we are live on YouTube. Yeah, and now I can share my screen. So we're going to use Slido for Q&A. Let me just figure out which screen to share. I'm going to share that screen. I'm going to go over here. So you can join at slido.com. And then the event code is DWW, or you can go to sli.do. But anyway, just go to slido.com and use the event code DWW. And just let me know, just to check how many people have logged in. I'm going to start a poll. Okay, I can't see you people, so I can't see if you're saying you've connected or not. But yeah, I'm going to start a poll right now. And I'd like you guys to just go to slido.com, connect to this event code, DWW, and then vote on this. It's pretty simple. Let's see those votes come in. No. Okay, we see some pacifists refusing to participate in the flame war. All right, guys, I think there's like 20 people on the call. We can get to 20. Slido.com, DWW, as it says right there. Also, for this section, at least, feel free to unmute and say hi. It feels very weird. It feels like I'm talking to myself, especially because I can't see you when I'm sharing my screen.
Tabs are more accessible.
Tabs are more accessible?
Yes.
Because it takes... accessible for accessibility. I thought it was like accessible for, I don't know, internationalization. I don't know. What do you mean? Because it takes one keystroke to put in a tab.
No, users with eyesight issues are able to edit it to be as big as it can be or as small as it can be.
Well, I have eyesight issues. I don't have a problem with it. Anyway,
just allergic to the sun.
We should not be having this war.
Okay, yes. Some have chosen to make love and not war. Awesome. I think I'm going to stop this poll now because it's clear that Spaces was won. People are still voting. Stop voting. Spaces has won.
Yes, Spaces has won.
Yes, we have, you know.
It's clear. It's clear Spaces have won. Okay, awesome. Now we're going to go to another one. This is just a mic check for Q&A and poll stuff. And this one is going to be a free text one. What's your favorite programming language? Kikoyu is not a programming language, unfortunately. Oh, Ryan, I know you're the one who wrote love.
Thought you said it was an anonymous poll.
No, it's anonymous. I just know you.
Decided to make him an anonymous now.
No, it's completely anonymous. Come on, guys. Love is the answer. It's a community stream. Is we do that. Yeah, looks good. Awesome. Shit. I'm going to stop this because
there's a clear winner.
Yeah, love wins every single time. Every single time. But love is also a meta language. So still, love wins. Love wins. I'm going to stop that. And Yeah, okay, sawa. Basi, it's Python basi. Sawa, umeshinda. Tutakuwa na ubaya. I'm going to stop that now. Aya, sawa. Now, we're going to, so now we are well acquainted with Slido. Interesting. We're well acquainted with Slido. We'll also use it for questions. If you're already logged in, apart from polls, you see the other tab is questions. So yeah, click on questions. And we will limit all questions to Ryan that you want answered to Slido so that we have a record of them. You can also upvote questions. So if you see a question that you'd like answered in there, you can upvote it. You cannot downvote, unfortunately, for you lovers of Stack Overflow and YouTube. You cannot downvote. So feel free to jump in there, ask any question that you want answered. We can keep the chat to any other content or any other questions that you don't want answered. And without further ado, I am going to stop that. And I'm going to introduce Ryan. Ryan, I don't even know how to introduce you. And now I realize that I should have asked for like a bio or something. But anyway, so our speaker today is Ryan Marvin, and the topic is developing serverless web applications in Python. Is that the whole topic? Or am I guessing?
Yeah.
Yes. Developing. So I don't have a drum rolls sound effect. So Ryan Marvin, take it away.
Thanks, Mark. I'm just going to go ahead and share my screen.
Why don't you introduce yourself? We don't all know you. As you share your screen, introduce yourself.
Sure. So I'm Ryan. I'm a software developer at Intella. I currently work with a partner called Paculate, where we build software for marketers. I've been working with Python for about the past 5 years, and in a good number of my roles, I've built serverless web applications. And today, that's what I'm going to be talking about. So what is serverless? So serverless is basically an approach to web application infrastructure where no permanent application servers are provisioned. But okay, most of you might say that yeah, maybe you've heard about serverless and there's actually a server before. There's actually a server rather, and that's true, but we'll get to that later. First, let's take a look at what traditional web app server architecture looks like. What we're most used to is a 3-tier, where you have the presentation tier, the application server, and the database. The app's application server is constantly listening for requests from clients. That's through the presentation tier. The presentation tier, the user using the presentation tier makes read or write requests to the application server, which then reads and writes from the database and returns the response to the user. After responding to the client, the app server goes back to listening. In serverless web architecture, it's different. It's more event-driven. So you have the same presentation tier for the user, but then the user is making the requests to an API gateway. And this API gateway triggers an event on a Lambda, thus creating the server. So a Lambda, for those who are not familiar, is basically a computer as a service. You can think of it abstractly as a function. Basically, you tell a cloud provider, do this function, run this job for me, and they'll just provision they'll figure out how to provision the servers to do it. In any compute power that's needed, they'll provision that. So all you have to worry about as a user of a Lambda is just writing out your function, essentially. So when the request is made by the user to the API gateway, this triggers an event, calls a function, and then your view logic is in this function. And it now goes to the database that reads or writes. returns the response to the Lambda, which then now returns it through the API gateway back to the user. Let's take a look at a simple Lambda that basically a hello world. Here, I created a function that prints hello world. This is the AWS console for Lambdas, and it has its own IDE here on the browser where you can type out your code, and when I hit test, it's going to run this function, this hello world function, and we'll see here there's the output hello world, and furthermore we'll see how long that took to run and what we built for. So AWS Lambda will bill for a minimum of 100 milliseconds. We'll get to more on how billing works later, and then you have some other statistics. So that's how basic Lambda works in a web application. Now, perhaps we'd have our view logic here, where we'd go ahead and grab the things, read or write from the database, do some operations, and then now return the response. Furthermore, we see here that there's two parameters that are given to this function. That's the event payload. So a Lambda can be very generic. You can basically source events from anywhere. It could be from now the API gateway in the context of a HTTP request, or maybe you have some files you're uploading somewhere. That event would get piped here along with its context, some extra context around the event. So that's what a simple Lambda looks like. What are the reasons for building web applications this way? That you don't have any permanent infrastructure to provision and manage. That since what happens when you make a request, let me just go back to the slide where we have the architecture. So when you make a request here, when the user makes a request and comes in through the API gateway and it calls the Lambda, this essentially creates the server at that point in time. And then once the server has finished serving that request, the Lambda goes back to sleep, like it's discarded. So you don't have anything constantly running to execute your request. It only comes alive when there's a request that comes in. So there's no permanent infrastructure that's running that you have to be constantly worrying about keeping it updated. Now, the other benefit of this is it will automatically scale to your traffics, because each request gets its own container. For those of you who have worked with Docker before, each request will have sort of its own container, its own execution context, its resources, its own resources, and you can have multiple concurrent requests that it scales quite quickly. And then you only pay for what you use. We saw here that we were billed for 0.2 for 100 milliseconds rather. Our function ran for 0.29 milliseconds. What AWS does is they'll charge 2 billionths of a dollar per millisecond of execution. So over time, this really makes a difference, because you're not paying for resources that are running 24/7, and you end up saving quite a bit on this. Some companies have even seen savings of up to 90% after to serverless web app architecture. And now, and the other benefit is there's little to no downtime, because AWS, you have the whole weight of AWS on this, since they're concerned with provisioning your the compute infrastructure when you're running any functions. They're concerned with keeping it up. There'll be very little downtime with this. Is the case with most cloud services. Since it's a managed service, you don't have to worry about it as much. And yeah, as I mentioned, the cost of execution is $2 billion over dollar per millisecond of execution.
Please click hide.
Yeah. Sorry?
Click hide.
Hide.
Where it says you're sharing your screen. Hide.
Okay.
Thank you.
Thank you. So let's build something. I will demo the small web app I built for this demo. It's a simple app that tells you the weather of a given city when you put it into this search bar. So right now, this is the weather in Nairobi. We can look up the weather in Kampala, 26 degrees. We can look up the weather in maybe Kisumu. Yeah. So an additional feature to this app is that you'll be able to add a subscription to get hourly weather SMS alerts for that given city. So subscribe to hourly weather alerts for Kisumu, and I'll put in my phone number. Nobody call me, I won't pick up, and I'll submit. We'll get the message successfully subscribed to, and yeah, that's all this web app does. So how does this work? We have the weather app front end, which is the UI we just saw. And when you type in to get the weather for a given city, it makes a GET request to an API. Now this is a serverless, an API built using serverless web app architecture, and it makes a GET request to the weather endpoint. This goes to the API gateway, and the API gateway forwards this request as an event to the Lambda, along with the headers, the body of the request, the route, query parameters, everything. And then the Lambda makes the request to the Open Weather Map API. That's where I'm sourcing the weather data from, and then returns it to the API gateway, which returns it to the front end. So that's it for the get weather. For the post subscribe, it's similar. Here we have a payload, which is the city for which to subscribe for weather alerts for, and the phone number that for the person who's subscribing. And the API gateway takes that request, sends it as an event to the Lambda, and then the Lambda then writes it to DynamoDB, which now can be used later when we have a cron job to send out the SMS alerts. And that's how it works. I'm going to walk you through the code for this, but before I do that, my approach to building it, I use the web app. I use this framework, Python Zapper. It's a framework that allows you to build serverless applications in a simpler way, and also to transform your Flask or Django applications into serverless apps. There's other existing frameworks like AWS Chalice, which I've also used before. It's a bit opinionated, and it will lock you in because it comes with its own. You can't really use Flask or Django with it. It will come with its own web framework. So and it's built by AWS as well, actually. And then there's the serverless framework, which is an NPM package. It's a lot more flexible, a lot more generic. So you can use it to build serverless apps for most languages. But then you may be smart and you may want to avoid JavaScript. So let's take a look at what the application looks like. So I'll just go ahead and dive into the endpoints for it's a Flask application. So we have the get weather endpoint, which is called with a city query parameter. That's the city you're searching the weather for. And then we'll call the API, the Open Weather Map API, to get the weather data for that city and return it as a response. The other endpoint is a subscribe endpoint, where it's a post request, the HTTP post request we make. In the body, we include the phone number, the city for which to subscribe for weather alerts for. And now we put that in DynamoDB and now return the response. The other thing is the cron job that I mentioned that will send out SMS weather alerts for every hour. Every hour for the subscriptions. So this is what the function for doing that looks like. We get all the subscriptions from the database, and then we fetch the weather alerts for that city that's associated with that subscription. So, for example, if it's Kisumu or Nairobi, we fetch that, and then we serialize that into an SMS. And I did, for purposes of keeping this demo simple, I didn't finish this function and actually have it send out SMSs just to keep things simple. So right now, all I do is just I log out that we're sending that message, but we're not actually sending any SMS. And that's it for the application. Now comes the this now is an application and can stand on its own. You can deploy to a traditional server as usual, and it should work. But now we use Zapper to make it a serverless application, and to do that, we ran a command called Zapper init, which allows us to generate the configurations for that we need for it to tell Zapper how to package and deploy our application. So this configuration file has on the first line the WSG application, the Python WSG application, which will receive the requests. So this is basically the module, the app module, the app object in the app module, which is right here. And then we have the AWS region to deploy to. I use EUS2 here because it's closest to Africa, have lower latency that way. The profile name, which is an AWS AWS CLI config file. That's basically the AWS credentials to use. And then the project name, the runtime, Python 3.6, and the S3 bucket to be used when packaging the application. We'll see more on this later. Where to store the envs. So the env configurations, that is, one of the configurations we have is the weather API URL and the API key for the weather API. And then we enable CORS to enable the web application UI to make requests to the API. And then we now then also set up the cron job for sending the SMS weather alerts. It runs every single hour and is handled by this Lambda. We'll take a look at this on the AWS console. So once we have the config set up, what we do next now is we'll run Zapper deploy. We're deploying to dev, so Zapper deploy dev. And what this does is it will package your Actually, let me run, since it's already deployed, let me just run Zappa update. So what this does is it will deploy, it will package your application first and all its dependencies into a zip file like this one. And in this zip file, you'll have every single Python module that party library that's required by your application to run. So here you'll see things like Flask, RESTful, Flask, because that's what I'm using. We'll see literally the request library which I'm using to make requests to the weather API, every dependency and dependency that your project needs, along with your application code app.py. So Zappa does this for us, and this is what it's doing right now. It's downloading those dependencies. An additional step that it does take is that it will compile certain packages to be more compatible with the Lambda environment on for AWS, because there's some minor environment considerations to make sure that this package will, because it's a different operating system. It's Linux AMI, and that's, yeah, it needs to have some of the libraries compiled for that. And then the other things that it does do is it will set up the Lambda on AWS. So that Lambda is this one. And then it will also set up the API gateway and set up routing, any necessary routing that needs to be done to route requests from the application, from users to the application, to the Lambda. And here we can see this on the, this is the API gateway AWS console. We can see that you have the client, and when they make this is for the root endpoint. When they make a request, it comes in through to the Lambda on this end, which is where the API dev that also set up by Zappa. And now once the Lambda processes that request, it just returns the response back to the client. So this console is also set, this API gateway resource is also set up by Zappa. And if we take a look at our deploy, we'll see it's done now. And it basically, it packaged the application, as we said, into the zip, uploaded it to AWS, and then also scheduled the cron job that we set up for sending SMS alerts hourly. And an additional thing is that it set up a keep warm handler, which is basically something to avoid cold starts. I'll go more into cold starts later, but to make sure this is just to make sure that the application starts off. So when a new request comes in, it will start off quicker than since it will have already been kept warm. We'll go into what that means later. And it gives us the URL of where the API has been deployed to. So this is what we can now use to put into the into our web app UI when you're compiling it and deploying it. So yeah, requests coming through to here. Other functionality offered by the Zappa framework is tailing application logs. So if we run Zappa tail dev since 1 hour, we'll get all the logs from the past hour. So quite a bit of logs here we can see the requests that were made to the Open Weather Map API, and we'll also see the request that we made to the application. This was triggered by the request we made to the application. We'll also see logs for the app initializing the connection to the database, and all that. So these logs are stored on AWS CloudWatch, and Zapper just provides you a nice CLI to go through the logs with. And another feature that it does provide is rollbacks. So let's say you deployed, there was something wrong with your deploy and you need to roll back. You can easily roll back with Zapper by running Zapper rollback and the number of versions to go back. So let's say we want to go back to 2 versions ago, and we can roll back to 2 versions ago and have our application running quite quickly. Now, I mentioned cold starts being one of the limitations, because there's several limitations that will come with serverless web applications, and we need to be aware of these because there's no such thing as a free lunch. So one thing that we have, as I mentioned, was the cold starts. That is spinning up the execution environment container on a new request. Can take a while sometimes. Think of it like again, I'll use the analogy of Docker containers, because that's what they use something similar in their backend. AWS uses that in their backend. You end up building the container from zero. It's not cached. There's no cached. When there's no cached build, when a new request comes in and AWS Lambda checks and there's no cached build, it's not able to. It will need to build that from zero, and that can take a bit of time, and that can add to the latency in your requests. So cold starts is something to be wary of, and how Zapper helps with that is it sets up now the keep warm handler, which will ping the Lambda every couple of minutes, and this will make sure that there's always something cached to be used when the next request comes in. The other thing is the stateless, that serverless web applications are stateless. That is, the execution environment is ephemeral and it's destroyed after each request. So when you have, let's say you have a request and maybe you want to write something to a file, maybe you're using your file system for storing, maybe for storing rate limiting, keeping track of rate limiting or something, and maybe you store like a token identifying the user and how long ago the last request was. This won't be there in your next request if that's how you're handling state. And so this needs to be kept in mind when you're building out your application, that you'll need some extra, either some extra external storage, or you can use, that's really the only way, some extra external storage, maybe the database, maybe you add a Redis cache or something. Yeah, you can't store anything safely on the Lambda and expect it to be there the next time. The other thing is you have less control over performance, and this manifests in that the maximum time a function can run is 15 minutes. So once that 15 minutes elapses, AWS will kill that request, that execution, and therefore you want to use this only for when you know your request will only execute in a short amount of time. The other thing being that the maximum event size that you can invoke a Lambda with is 6 megabytes. So that means you can't have any big uploads. Like let's say you're uploading a file, you'll need to use a separate, maybe a separate service for that. Maybe use a CDN, have users upload the file to the CDN, or find a different way of approaching that. I ran into this problem when I was trying to support image uploads to a serverless API, and you ended up having now to use a CDN. The other thing is memory is limited to 3 gigabytes max, and this can't be modified. The documentation does state that you may reach out to AWS in case you need some more resources, but these are hard limits, and you'll probably run into them before you anticipated them. And so that's another thing to keep in mind. Then there's also limits on how many concurrent requests can be served. It's set to 1,000. That is, you can only have 1,000 concurrent requests per second. But this can also be modified upon reaching out to AWS support. Then one of the most important ones for me, I feel, is the environment is difficult to faithfully emulate in development, because AWS does provide certain tools that you can use to emulate Lambdas on your development environment, but it's not always up to date. It's always trying to keep pace with now what they deploy in their production, and you end up not being able to have reproducibility, build reproducibility in your development environment, which can be a very important thing to have. And this also now means, let's say there's an error in production, since you can't even SSH into the Lambda because it's closed, but you can't SSH into it. Reproducing that bug, you need to be very careful about how you approach logging, and make sure you have enough context as possible to solve any bugs that happen just from the logs, which should be the ideal, even with traditional web applications. And the next thing is vendor lock-in. So one thing, AWS is not the only provider for Lambda. They're not the only ones they're not the only cloud service provider that you can build serverless web apps with. As you have Azure functions as well. I haven't gone over them in this presentation, but the concepts remain mostly the same. You have compute as a service. You basically, and it's event driven. So you have an event, a HTTP request is the event, and you have the function which now processes that event and gives you an output. So the request is the input into the function, the response is the output of the function. So it's the same thing with Azure, it's the same thing with, there's another open source serverless service by Apache. Moving between these providers becomes very difficult. You'll find yourself taking up more and more AWS services if you're using it. You end up being locked in, and sometimes this isn't very ideal. It's not an ideal trade-off depending on what your requirements are. But at the same time, the flexibility provided by this and this cost savings ends up being worth it for some use cases. So it's really on a case-by-case basis. And the next, and how to figure out, so how do you figure out if serverless is for you? There's this service, there's this service called servers.log, where you can basically put in the requirement, what your application, the kind of load you expect for your application, and it will let you know if serverless is a good fit for you. Something else I didn't mention is that AWS Lambda will only support certain languages for serverless web apps. It's most common web languages in use today. So Python, Node.js, Ruby, PHP, and a couple of others. And that's also another limitation you need to keep in mind. And so we'll choose Python for our weather app. And can the functions in your app finish in 15 minutes? Yes. And we'll put in the name of the application, how many requests we expect the application to receive. Maybe we get about 500 requests per minute. And then how long the average request duration will be. We can assume 100 milliseconds, and how much memory your app requires. Maybe we can put 256, and the graph that represents our application activity. Maybe people wake up and they'll check the weather in the morning, then maybe they're going out for lunch in the afternoon, they check the weather or something, and then maybe check the weather before going home. So let's pick something that looks like this. And then the EC2, AWS EC2 instance type that our application is currently running on. And maybe we can put something like T2 large. And yeah, let's see what the cost savings would be. So yeah, our application is a good candidate for serverless. Using the web app, we'd be using Lambda, we'd be looking at $13.32 per month. If we're using an EC2 instance, it would run into $66 per month. And yeah, the cost saving here is obvious, despite some of these being estimates. I'm sure this tool can provide a lot of good insights for what you're using, and give you a rough idea of what your costs would change like. And that's it. So to summarize, serverless is an architectural approach that relies on compute as a service, as opposed to having permanently running infrastructure. Serverless infrastructure automatically handles scaling, maintenance, fault tolerance, and builds for only what you use. And serverless web applications are stateless. And Zappa is a Python framework that helps with the deployment and development of serverless WSGI applications like built-in Flask or Django or any other WSGI web framework. And that's it. Questions?
Yes. Oh, okay. Thank you, Ryan. There are a couple of questions, I think, on Slido. I'll just share my screen again so we can all see it.
Okay.
In case. What screen is it?
So I hit the. Okay, I think that should stop.
Wait, what did you eat? You said you ate something.
I had hidden the hide button. So.
Oh, you hit the hide button. Okay. But you said you ate the hide button. Anyway, yeah. So there's currently like 3 questions. Ryan, go for it. Starting with
Sure.
the top one.
All right. So how many functions can you have, or is it just one? I'm not sure how it would scale if all application logic is in a single function. So you can have, I have just one, in my case, I have just one function, and it doesn't matter. So a function, you can think of it as abstractly like a deployment. Let's just call it a deployment, and AWS handles the scaling of it. So there's one call of the function, and it gets its own execution context. It gets all its resources that it requires allotted to it. Each request gets that, and this is how it's able to scale. So you can think of it sort of like as an endpoint, HTTP, an endpoint on a HTTP app. You have just one single endpoint, but then behind that endpoint, you might have like 6 servers that the request can be routed to. Maybe so. Yeah, you can think of it of a function that way. Is that? I hope that answers your question.
I see you avoiding to like say that name. It's either Mkula or Mkula. I don't think there's another way it can be pronounced. Or Mkula, I don't know. Does that answer your question? I hope still on. They are still on the call. Yeah, I guess it answers that question.
Okay.
Next one, which fonts are you using, Ryan? Which font?
I'm not sure. I set it so long ago, but I'm trying to check now. I think I'll check it and let you know later. Oh wait, I found it. It's called Fantasque Sans Mono. Yeah.
Jesus. Okay, could you post that in chat?
Okay.
And yes, I'll read the next question from Anonymous. What is the next? Jesus. What is the effect on cost of running the Lambda function if Zappa keeps periodically pinging them to keep warm?
That's a really good question. So I'm not sure. I'll need to check that up and get back to you. But I do not think it should have any effect on the cost significantly, because you build. Sorry, there's a plane flying over. So you build only for how long it takes to execute, and let's say it's being pinged, and that's okay. The minimum is 100 milliseconds, and our keep warm is 4 minutes. You end up having a small added cost onto it, but it will only be for, as I said, it's 2 billions of a dollar per millisecond of execution, and if the minimum is 100 milliseconds, so you have maybe two millions of a dollar in a day. That ends up being really insignificant sense, probably, to keep that keep warm running. But I'll try and get the numbers and get back to you.
Luis, then Quasimodo wants you to share the slides and code.
Sure thing. I'll do that on general after this call.
Yeah, but we're not about sharing code. They should pay for it anyway. Zero had raised her hand. I'm going to stop sharing now. Zero had raised her hand at some point. Yes, Zero, you can speak. Zero. Or if anyone else has a question that they were not able to put on Slido. Sense mono. No, no. Okay, no more questions. Okay, awesome. So if there are no more questions, that is pretty awesome.
Hey,
Yes, speak.
Mkula was talking. You just cut him short. I don't think you could hear him.
Oh, okay. I can't hear him.
Well, Mkula, you can go on. And I think Mark, you can go on.
Are you sure he was talking? 'Cause I don't know. I couldn't.
Yeah, I didn't hear him also. So maybe Stanley could repeat his question.
Yeah,
It
Stan.
wasn't
Oh,
a question. Yeah, he was just saying, he was telling Ryan, just thank you for the presentation. That's all. That's what that's what he was continuing to say.
Oh my God, this was Ryan. Did you hear that?
I didn't hear that. But thank you.
Yes, Stan can hear people's inner thoughts. I think that's the voices in your head, Stan. You should have that looked at. Get professional help. Sawa sawa. Okay, so I'm going to start. Stan, it's okay. It's okay. We tunakupenda tu wenye huko. Kama yeye. Okay. Seems a select number of people had it. Okay, awesome. So I've started another poll on Slido. Yeah, I should probably share my screen again. Oh, shit. You guys are already voting. It's what topics you'd like to see us cover in future workshop. So there's lots of options. You can scroll down. If the first options that you see are not exactly what you're interested in, vote, vote, vote. Meanwhile, is Jira back?
Yes, I'm back. Can you hear me?
Yes.
Mic check. So, Ryan, for REST API that is serving different HTTP actions to different resources, would you advise breaking each resource to its own Lambda function?
That's a good question. So personally, I think it depends on what kind of load you expect the application to receive, because then it's basically the question. It's the same question as should we have distributed architecture, and it's the same because it's the same problem. Now, if you're having, my answer to that question is always if you're having enough load, enough traffic coming into that monolith, that's a good sign that it's starting to get strained. That's a good sign that you should break it off into its own application. So maybe you have one hot endpoint, and that could be a candidate to be broken off into a separate Lambda. Does that answer your question?
Okay, so funny story. I've lost my internet at the beginning of your answer, and I've just rejoined.
Okay, sure. I'll go again. So my answer to that question is the same. It's really a question about should we have distributed architecture? And my answer to that question is if you're having enough traffic, that's a good sign that you should break your monolith down into separate pieces. So a good sign that you should maybe break off the multiple endpoints on the Lambda is maybe you're having lots of load, lots of traffic coming to that Lambda. And maybe it's not even to all the endpoints, maybe it's to one endpoint, and you can call it a hot endpoint, and that would be a good candidate to break it off into its own Lambda. You do get the same distributed, the same problems that you run into when you're having distributed architecture. So it's not a decision to be taken very lightly. If you're starting off with a small application, I'd really recommend have one Lambda from the beginning and then let it break off organically.
All right, thank you.
Nice. Votes are still coming in for what topics you'd like to see covered. Please, if you haven't voted, there's like a couple, I think like 30 or something people on the call. There's more people on the live stream. I think like 20 something people on the live stream. People on the live stream can also vote. Please vote for what topics you'd like to see covered in the future. System design is currently winning. Vote. I'm about to close it. Let's get to 30 at least, and then I'll close it. Okay. Cool. So we're about to wrap this up. Just going to close this. Yes, 0. Yes. Okay, cool. And then, yeah, about to close this up. Thank you very much, guys, for coming. And a very special thank you to Ryan. I think we've all learned quite a bit. That was pretty informative. Yeah, I think I'm going to go build a Lambda now. Before I finish up, just so that we don't lock anyone out, does anyone have a question, burning question, a comment, a compliment, a complaint, before we do like one final poll, and then we can call it a workshop Wednesday? And Kula, this is your chance. Or Kula. Or Stan, you can tell us what Nkula is saying. Right. I've put up another poll. How would you rate this workshop? The content, the speaker, etc. Don't be too harsh with us. It's the first time we've organized this. Also, please be a bit harsh with us. Don't be too nice. And feel free to reach out to either Jojo, myself, or Shiko if you have any suggestions, any complaints, compliments, etc. Shiko, I don't know if you have anything to add for the wrap up, as people tell us how they liked the workshop.
I'm just very glad that everyone who was able to make it today, welcome, and we'll keep this going to the best of our ability. And also, we will probably need people who would like to present things on Workshop Wednesday. Please feel free to reach out, and we can schedule something with your presentation. So, yeah.
All right, thank you very much, Rico. Sawa, I think ni hivyo. You can continue voting. I won't close the how you rate the workshop poll for like another 5 minutes. You can continue voting on that. Again, feel free to reach out to us, Shiko, Jojo, or myself, if you have any, if you just like to talk or have any feedback. Also, feel free to buy Ryan a juice or give him a high five, but sana juice when you see him around. And thank you very much, Ryan, and thank you, everyone. It's a wrap, Kamoi. Bye.
Bye. Thank you.
Bye. Thanks.
Bye-bye. Thank you.
Bye. Thanks.